So now, if you would like to determine a range or R, how can you determine it? Because you already know about the t that it takes to the height maximum, right? Which is this t equal to u sine theta over g. If you would like to determine about the r, you know, from x direction, what is happening? It's happened only v equal. What is happened? It's happened only x equal to vt, right? If you know v in terms of x. So the range that this part moving with the velocity in x component, which is your vi cos theta, and multiplied by t. Since the upward, it takes th max time. So when it's going to the ground, it's gonna take the same amount of time, so that you get the time that travel along the x that reach to the range. So this cost time that go to the maximum position along x-axis is equal to t that take to the maximum height. So now you're gonna sub tr that equal to 2u sine theta over g into this equation. So with x that sub with tr in, you're gonna get the range out of it. So that equal to Vx, right? Vx is u cos theta, and sub t into u sine theta over g. So you're gonna get a range as u square sine theta cos theta over g that multiply by 2. With this relation, like 2 sine theta cos theta from the trigonometry, right? 2 sine theta cos theta is equal to sine 2 theta. Here, as u to resub to vi square sine 2 theta I over g. This is your range in meter. And this is how you find the height and range as this. Before we do some derivation on this part to determine whether you have the x, that particle moving along, or y, that particle moving upward, with the relation of time. And then we can sub all this information in, right? And with this characteristic, we got sine 2 theta. So that you can find the height of it, and you can also find the range of it as well. This is the summary of what we did in example 4.3. As a result of the solution from the height and from the range, you can see the effect of projectile motion in symmetry that have the same initial velocity from the ground. If you have different angle here, it's corresponding to the different range and also different height as well. If you expect to have the maximum range, you should use the theta around 45 degrees. And then whether you have the higher one or the low one, it can reach to some specific range and also with different height for this projectile motion. For this question is for non-symmetric projectile pathway. So this guy, rather than stand on the ground, now he throwing some object, throwing the stone from the roof of this building. And they have the angle of this from the x-axis around 30 degrees. So what is happened? If you cannot remember the relation of what we proved initially, we can use the relation of what we have learned in 1D motion and break components for calculate in this part as a 2D motion. So what is happened now? So what is said about the initial speed of this stone has been thrown as 20 meter per second. So this is initial u as 20 meter per second, and the theta is 30 degrees. If I would like to break a components, because I would like to calculate separately in x and y direction, so I got ux as u cos 30, which is 20 cos 30. This is ux. And uy, if I break it out, it's going to be u sine 30, which is 20 sine 30. So I write down here the ux component that I got is 20 cos 30, which is 20 cos 30 is root 3 over 2, right? And uy is 20 sine 30. Sine 30 is 1 over 2, so that I got these as 20 and 1 over 2. So finally I got this 10 root 3 meter per second, and also 10 for y components. These are initial velocity in each component. What is throwing? It's throwing with initial velocity, so in x direction there's no acceleration. However, in y direction, it has the acceleration equal to minus g. If in this case, I would like to use g equal to 9.8 meter per second square, the question is asking about how long does it take until the stone reach the ground. So the displacement, you know, from this point to this is 45 meter. But if you look after the direction, you can see the displacement here along y direction is minus 45 meter. If you would like to determine in A, how about T that reach to the ground? So you can use the information of your initial u, and you separate and do calculation only in y-axis. This part, you can answer about the time that this stone reaching to the ground from your four main kinematics equation. So which one that you have the information of u, y, you have the information of g, you know the information of s to find t. Think about that. So that's supposed to be your third equation, right? The s equal to ut plus 1 over 2 at squared. If you rewrite in terms of y-axis, so now you're gonna get y as a displacement, so it's supposed to be y minus y0. So I can write down as a sy over here, and u, which is uy component multiplied by t plus 1 over 2 ay t squared. Now you sub all the information you already know. The displacement is minus 45. The uy is here, upward position, because it's throwing to this direction, so uy is in upward direction. So it's plus 10 multiplied by t, and then you have 1 over 2, and your a y, not ax, sorry, this is your ay, is minus 2 is equal to minus g, which is minus 9.8, right? And t square, I have to say that please note about the sign, whether it plus or minus is quite important, because all of these calculations supposed to calculate them according to the vector. I will rearrange this term, and when you rearrange it, you will find that the final term is 9.8 over 2 t square, and you got minus 10t minus 45 equal to zeros. So finally, you're gonna get t that reached to the ground, that stone reached the ground, equal to 4.2 seconds. With t square, you have two values, but the value that you're gonna use is supposed to be the plus value. In order to determine the speed of this stone before striking the ground, so you can use the relation of the displacement and also the relation of things that moving along the y direction to do a calculation as well, because you would like to determine the speed of it, right? But think about this speed now is not happen only in y-axis. It also have the speed in x-axis as well, which is the speed at the ground comprised of the vy and vx. The speed supposed to be the total v, which is the component of vx square plus vy square. So this is supposed to be speed on the ground when it strike the ground, right? Maybe I will not write on, it's just before the ground, just before hitting the ground, right? You like to determine this term. So do you know about the Vx? Yes, Vx we already know. It's constant, right? Because there is no acceleration along x-axis. So your Vx is equal to 20 cos 30 degrees, which is, we found it already, right? It's 10 root 3 in meter per second. If you write as a vector, it can be Vx equal to 10 root 3 I direction, like this. So now our job is to find Vy. How to find the Vy? We know the relation of the displacement, right? We know the relation of the initial velocity, which is uy. We know the condition of the acceleration, minus g is equal to minus 9.8 meter per second square. All these parameters we know, right? So if we like to determine Vy, so you can select whether you want to use a time relation as well, because we calculate about the time in A. So I will pick up one, and that might be the fourth equation of 4 kinematics equation. So I will pick up the v square equal to v0 square plus 2as. If you write in terms of y component, because we consider y component, it can be vy square equal to uy square plus 2ay s, that in y components, or it can be h or y. It depends on what you would like to determine about this displacement in vertical axis. So from this relation of your y components, I will sub the information that I know in. So v square is what you would like to find, right? How about u? You know u is your y is your 20 sine theta, right? Or sine 30, which is equal to 10 meter per second. So sub this u in, so it's 10 square plus 2, and your a is minus 9.8, right? This is plus 10, this is minus 9.8, and your displacement is downward, so it's minus 45. So finally, you're gonna get your Vy as a square root of 10 square is 100, and you multiply this term like 2, 9.8, and 45 under the square root. So finally, your Vy as a result, you get is equal to 10 root 10 meter per second. This is your Vy in J components. However, since your Vy is moving downward, so the size of your Vy supposed to be negative, right? Because as you can see here in this code, our Vy is supposed to be the negative size, because you square it up and you take a square root, so it's going to be plus and minus size for this case. So your Vy should have the negative size. So finally, if you would like to write down about the magnitude or finding the speed of it, you find the square of each individual components. So finally, I will write down here because we lack of space over there. So your v is equal to square root of vx square plus vy square, and this is 300 plus 1000, right, under square root. So it's 10 over 13 meter per second, 10 square root 13 from this calculation. So you got v as your final answers, right? Or you can write, I will remove on this part, you can write the final velocities. If it's not asking you about the speed, if it's asking you what is the velocity, how can you answer to this question? The velocity is the combination of vx component in I direction and vy component in j direction. So your v as the velocity on the ground supposed to answer as 10 square root 3i and minus 10 root 10j in meter per second, right? Because it's pointing downward for vy and pointing forward for vx. If you would like to answer precisely, this is supposed to be the negative side, not the plus side. The reason I already told you, because square root forces it to be positive, but you know about the direction of the motion. That's why it's supposed to be a negative side here.